Okay, I want to show the application of the quadratic equation that I encountered years ago. Um, I remember the problem. I had to fill in some of the numbers, like the customer's package and so forth. But basically, there was an existing two-axis test stand machine. That the customer got a new package, and my task was to design a new counterweight. Now the new counterweight had to mount like the existing counterweight did, so it had to have the same ID and OD, but it all had to balance about the horizontal axis, which you could think of as like a cradle. So if the customer's package is 100 pounds and the center of it is 24 inches above, and on the one side of the equations, we're going to have force times distance, which is 100 pounds times 24 inches, which is 2,400 inch-pounds. And now on the lower side, where the counterweight is, now the counterweight is a tube shape, and it's going to be made of steel, which has a cubic weight of 0.28 pounds. And now, so I'm using the equation to figure x, the length of the new counterweight. Now, x is going to determine the weight of the counterweight and also the distance that the counterweight is from the horizontal axis. So on the other side of the equation, I have pi, well, we know pi r squared is the area of a circle. So the OD of the counterweight is 12 inches, and the ID is radius is 6 inches. So 12 squared minus 6 squared, which is 144 minus 36, times pi, times the length of the counterweight, which is x, gives me the cubic volume in inches. I multiply that by 2.8 to give me the weight of the counterweight. Okay, so that gives me the force or the weight. Now the distance of the counterweight, the center of the counterweight from the horizontal axis is 10, it's a given, plus 1/2 x. So the distance is 10 plus 1/2 x. Okay, so I do the multiplication, and I come up with 95x times 10 plus 1/2 x. And then I come up with 2,400 on the one side equals 950x plus 47.5 x squared. And then I put it in the standard quadratic form for A, B, and C. And then I plugged it into the quadratic equation, and I come up with x equals 2.2689. Then to check it, I plug that number into the 95x times 10 plus 1/2 x, and I come up with 2,400 which is inch-pounds, and that matches. Now I also used completing the square method, which I actually just learned on YouTube recently. And I take the 47.5x squared plus 950x minus 2400 equals 0 from the previous page. And then I moved 2400 over to the other side of the equation. Then I divided both sides of the equation by 47.5 to get x squared by itself. And then the b component, I divided by 2 and squared it, and then you put that on both sides. So then I came up with x squared plus 20x plus 100 equals plus or minus 150.526. Then I was able to factor that just by looking at it, which is x plus 10 times x plus 10, which equals x plus 10 squared in parentheses, equals 150.526. And then I took the square root of both sides. I get x plus 10 equals plus or minus 12.2689. Then to get a positive number, x equals 12.269 minus 10 equals 2.2689, which was what I got when I used the quadratic equation. Anyway, I hope you enjoyed this, and I just thought it's nice to see a practical application, and that's all.